So yesterday we have discussed how to process big data, store and process. So in big data we have for big data processing we are using Hadoop. Okay. In the Hadoop, to store the files, we are using HDFS, Hadoop File Management System. To process the data, okay, resource allocation, we are using MapReduce. Later, it was using Spark. Okay, for processing the big data, for storing the big data, we have Hive. And there are other databases like Pig, like that, but mostly these are the three things we need to remember. Okay, why I'll tell you now today we are and also we have completed data OLTP versus OLAP. OLAP nothing but a data warehouse. Okay, so one database we use for transaction, another for analytical purpose. So most of the historical data will be there in data warehouse as well as in data mart. So these two we call it as OLAP. Okay, the fourth one, yesterday we have discussed about data warehousing. In the data warehousing, right? So how we are getting the data? We are getting data from multiple source systems. So now today we are going to discuss how these multiple source systems are processed into the data warehouse. How these multiple systems are processed into the data warehouse with the help of ETL tool. Okay, by using this ETL tool, we are going to connect with these source systems and we are extracting the data, transforming it and loading into the data warehouse. So this ETL means E means extract, T means transfer, L means load. Okay, next. Okay, so what will happen if I'm not using ETL or data warehouse? Assume you have storing multiple information in multiple databases. Now you, if you want a report, you can easily generate. Okay, the developers can easily generate by transforming it to the required tables. Okay, but if you want the data from these three tables, it's very hard to merge this data. So that is the reason we store information in a data warehouse from multiple tables with the help of this ETL. So this ETL will extract, transform, and load it into the data warehouse. Okay, without ETL, okay, without data warehouse, you cannot generate a proper report. So if you want to generate day wise, monthly wise from multiple tables, so rather than connecting with multiple databases, what we do by using ETL, we'll process and store it into the data warehouse. Okay, so what are the techniques we follow for this ETL? Okay, let me go with the paint. So this is OLTP database. This is a data warehouse. Now, so I bought some ETL tool. Okay, I got some ETL tool. It may be Informatica, Talent, anything. Okay, this is a ETL tool. So first, what this ETL will tool? Okay, this ETL tool will have a connector. Okay, by using that connector, we will connect with this OLTP database. Okay, next step. Okay, next step will be it will transform into the business requirements. Okay, what is transforming? And then it will load it into the data warehouse. Okay, so first what we are doing with the help of this ETL tool, we are connecting to the OLTP database. Okay, and we are extracting the data. Okay, after extracting the data, this ETL tool will have some database. Okay, in the database, we do the transformation, and then whatever the data we transformation, nothing but data cleaning, removing nulls, headings, unwanted characters. We'll write all the conditions in the ETL tool. Okay, this ETL tool, based on our condition, it will process the data, and finally it will load it into the data warehouse.
So
Here,
does a Snowflake is also called as ETL tool?
actually, Snowflake has a ETL feature, but it cannot do for all the source systems. Okay, it has some limitations. So I'll tell you what are the
Okay.
limitations. But we can do this ETL in the Snowflake.
Okay.
Okay. Next, so we have some techniques for extraction. Okay, so there is a methods, full extraction, incremental extraction, like that. Then for that a transformation, nothing but data cleanings. We already discussed removing duplicates, nulls. So these are the SQL functions we have for to do the same. Okay, change cases, fix data types, remove unwanted characters. All these are, we call it as a transformations or data cleaning. Okay, next, last one, loading. While loading the data into the table, we have some techniques like SCD types, and then we have methods, insert, update, merge, upset, like that. We have multiple things are there. So we use this method based on the client requirement. So E means extraction. So it will connect with multiple source system and it will extract the data. Then it will transform based on our condition or based on our script, and it will load into the data warehouse with these methods. Okay. Okay. What we have two type of techniques. One is ETL, another one is ELT. Okay. So in Snowflake we use ELT. Why? I'll tell you. Okay. As a previous example only. So assume there is a data warehouse in on-premises environment, nothing but VPS server. This is a cloud server. Okay. So this is a data warehouse. Right. Now now, if I'm inserting, this has 1 TB of SSD or 16 GB RAM or something. Okay. Now, if I use extract and load directly without transforming, if I am doing extract and load, what will happen? The duplicate data will stored into the what we call into our data warehouse. The problem is, like, if you are inserting duplicates, unwanted cards, everything, okay, whatever the data you are getting, if you are storing like that, okay, within a 1 year, this 1 TB will get filled, and next time you need to do some migration activities or upgradation, something. So some activities you need to do to increase the server size. So here the storage is very costly. That is the reason while loading the data, I use ETL technique, which means I'll extract, I'll remove all the unwanted data, duplicates and everything. I'll transform it and load whatever the business data I required into this layer. Okay. When it comes to cloud, when it comes to cloud, when it comes to cloud, so the storage capacity is infinity and the pricing is very cheap. So 1 TB is $20. Here, if I need to get 1 TB, I need to pay around 4 to 5 lakhs rupees for this server. But here it is very cheap. Here it comes with $20, 1 TB, $20 per month. Here, one time investment, 4 lakhs, but every month again, I need to pay $200 to $300 for the rent and maintenance on average. Okay, now here, the storage is cheap. So that is the reason whatever the data I'm getting, first I will store it into this cloud account. Okay, any cloud. It may be a BigQuery, Snowflake, Databricks, anything. Okay, here the storage is cheap. That is the reason whatever the data I'm getting, I'll store. Initially, I will first store the data and then I'll transfer. So that is the reason here we use ELT. Okay, here what we are doing, we are extracting the data, we are transforming and we are loading the limited data. But here what we are doing, we are extracting the data, we are loading whatever the data I'm getting here. Okay, so here I am using ETL, here I'm using ELT. For both the data I'm extracting, just First I load into the data warehouse. Okay. Now here the computing is costly. I need to pay for warehouse, right? Okay. If I'm using 16 GB warehouse or 32 GB warehouse, I need to pay $1 per 1 hour, like that. Okay, but here it's free, right? Because the server will come up with RAM. So for processing it here it is free. That is the reason extract, and then I'm doing transform, and then I'm loading. But here the transformations are costly because I need to pay per hour. Okay, that is the reason why whatever the data I need to process, only that records will process and stored in data mart. Okay, or any layer. Okay, whatever the business required data will be there, right? See, I want to generate a 3 months of data. So what I'll do, I will process only this 3 month of data and I'll store it here because I need to pay per hour 32 $1 per hour. I need to pay per hour $1. Okay, that is the reason I'll process only limited data. So extract, and here storage is cheap. That is the reason I'm storing the data, whatever data I'm getting. Here the transformation is costly. That is the reason I will not process entire data. I'll process only limited records. Here storage is costlier, processing is cheap. So most of the data warehouses storage is cheap, processing is very costly. That is the reason they choose ELT, which means extract. Whatever the raw data is coming, they will store. Whenever they require the business reports, then only they will transform that particular limited data. They will not transform everything. They will transform only limited data. Here storage is costly. Okay, that is the reason. Whatever the data I'm extracting, first I will transform and then I'll load it.
In what scenarios will the companies use ELT?
See,
ETL, sorry, ETL.
yeah, that's what I'm saying. If you choose on-premises server, okay, like Oracle, PostgreSQL, there are companies they are using Postgres, Oracle, MS SQL as a data warehouses. Now, most of the banks are using MS SQL for the data warehousing. Okay, they use this ETL technique.
Okay.
Now, what are the companies that are using cloud, right? They are using ELT technique.
Okay.
Yeah, very simple reason. In the cloud, storage is cheaper. That is the reason. Whatever the data I'm getting, I load it into the data warehouse. But in the cloud, the computing is very costlier. That is the reason we transform only limited data, not all the data.
Got it, sir. Thank you.
Okay, so this one you can read it. Okay, if they told there is a concept called full load, which means I will truncate and load. Okay, if they told upset, okay, upset nothing but first what I'll do, I will match the two tables. Okay, if the ID matches, I will update the record. If ID doesn't matches, I will insert the record. This we call upset method. Third one is incremental method. So identify and load new record mostly based on date time. So there is a date time column. Based on the date time column, I will load the data into the data warehouse. Okay, so we have multiple ETL tools available. If you are going with AWS and GCP, mostly they use the Spark, Apache Beam, and for scheduling they use the Airflow. Okay, if you take Azure, we use ADF for what we call extract, load, and scheduling. We use this ADF. ADF will support both three: scheduling, extract, and load. Okay, again for transformation it varies. Okay, if you take on premises, these are the tools available: Informatica, Fivetron, Metlian. Okay, these three are but trending. Informatica, Metlian, Fivetron are third party tools. Most of the companies they are using this for extracting and loading. And for AWS, we have this AWS Glue. Okay. So these are the tools available in the market. Again, this is separate codes for each ETL tool. You have different job openings and different roles. Okay, and finally, data mart. Okay, now here in the data warehouse, Here in the data warehouse, I have a historical data. My business is from past 10 years. Okay, in my table, I have around 100 crores records. Okay, now if I want to generate one graph, okay, if I want to generate one report, now for generating this report, okay, I cannot connect every time to this table and processes, because even though we have a data pruning also, but it need to read the metadata, right? For 100 crores records, reading metadata is somewhat typical to do. It takes 3 to 5 minutes, assume. Okay, that is the reason what we do. Okay, so this report is related to last 1 year of data. Okay, this report I want is related to last 1 year data. So what I'll do, I'll create data mart, nothing but it may be a database, it may be a table, or it may be a materials review, anything it may be. Okay, I'll create one data mart, and then what I do, I will transform the limited records, that last 1 year records into this data mart. Okay, data mart may be a database, it may be a table, it may be a materials review, it may be another application as well. So we can build a data mart in any way. Okay, now what these guys will do, then collecting data mart and extracting the data from data warehouse, they will connect to data mart and they will extract the data. Because it has a limited records, last 1 year records, for processing it may take around 30 seconds. Here it is 5 minutes. Okay. So data mart is a subset of data warehouse focusing on specific business line, department, subject areas such as sales, marketing, finance. When targeted data repeatedly designed to serve specific needs of particular group within an organization. So these data marts are created based on categories, based on the size of the data. Okay. Data marts allow for faster access, relevant data for analysis and decision making, built to improve performance and simplicity. Data marts are designed around a specific subject or function, making them more focused and streamlined that enterprise version. Okay, just go with this thing. If I read it, it will take again a lot of time. Just go with the PPT and read the document. Okay, and next, uh, in, so in this data mart, we have these things. So we need to check the data quality, ensure the data is accurate, consistent, complete, and reliable for analysis and decision making. And the last one is in the data mart, we do this data modeling. Data modeling involves designing the structure of data, including relations, constraint, ensure efficiency and storage and retrieval. So here, what we do here in the data modeling, right? We create relations between the table. We create ER diagrams, and we'll share with the BI developer. Okay, this is what my data has stored, and we have processed and stored the data. Okay, so overall, this is the thing. So we have multiple source system. It may be a database, it may be a multiple files, it may be API, anything. So by using this ETL or ELT tool, I will connect with this multiple source system. I will extract the data. I will transform and load it into the data warehouse. So from data warehouse, based on business specifications, I will create multiple data marts and I will load the data into this data marts. So on top of these data marts, so these analytical teams will generate the reports. Analytical team may use Tableau, Power BI, Lookers, etc. Okay. If you are using cloud, so what they do, they will EL only. They will do extract and load into the data warehouse. In the data warehouse internally, they transform the data from one layer to another layer. Clear? Okay. If you take unstructured data, nothing but images, videos, all those things, how it will be processed. Okay. Assume, take a Google app. Okay. Take any picture. It may be a vegetable or fruit. What it will do, after taking the picture, it will analyze and it will give the results. What is happening here? Okay. Very simple. Very simple. So you may written in Spark or Beam. Okay. So already assume it's a Google data lake means a GCS, Google Cloud Storage. In the Google Cloud Storage, we have multiple folders. Apple, what we call these things. Apple, some vegetables like brinjal, like that. Okay. Now, if you have taken the photo and this Spark will process the data and it will analyze what are the characteristics that image has. So that image is round in shape, red color, this. Okay, it is similar to this Apple folder. Okay, then it will compare with the folder images. Okay, wherever the specification matches. Okay, it will confirm this 90% Apple, and wherever the content related to Apple in our database, that will be extracted and displayed in your web application. So data lake is for storing unstructured data. Okay, we'll extract unstructured data, we'll load it into the data lake, we'll process by using this Hadoop and data warehouses. Okay, so and here there will be a data scientist AML team for future predictions. They may use Python, or the Databricks is providing inbuilt AI, Snowflake is providing inbuilt AI. So they use this AI to process this for predictions, for creating Cortex AI, Gen AI, Streamlit, all those things. To generate all those things, they use this database data. Clear? Any doubts? This is called a $1 million slide, where most of the companies will use this slide. Any doubts? Anyone having any doubts?
Clear, sir.
Yeah, these are the things we do. Okay, these are technologies and the meaning. Okay, here I provided you. Just go with the slide, and then. So this is the architecture of Netflix. So as highlighted before, so we have application front end, middleware, and database. Nothing but OLTP. Okay, so here the front end will be the JavaScript and React, and mobile app. They are using this. Okay, by using this middleware, nothing but Java, Spring Boot, and Zool, initially they are loading the data into the MySQL. From MySQL, using Apache Spark, this guy is processing into the Amazon Redshift. Okay, for videos, for unstructured data, they are placing everything in the S3 bucket. Okay, by using this Kafka and Flink, they are processing for the front end. Okay, so for this is for deployment purpose. The pipelines, deployment pipelines, this come under DevOps bucket. Okay, our things are like this thing: data storage. For unstructured, they are using S3. For structured, they are using Redshift as a data warehouse. Okay, for batch data, they are using Spark. For streaming data, they are using this Flink, Kafka and Flink. Okay, so mostly for videos, they are using this Flink. Okay, for reporting, they are using Tableau. Clear? This is the Netflix architecture. So how they build the pipeline. So right? So for batch processing, right? Batch processing, nothing but every day the jobs will be scheduled at particular time. So that scheduler will trigger the script, and it will load data from OLTP to the data warehouse. Okay. There is a concept called batch processing. Okay. What this batch processing will do? Sorry. This is, we call it as a real time processing, batch processing, real-time processing. Okay, in the real-time processing, what we are doing, okay, whenever changes happen in the app, that will get reflected. Okay, if the delivery boy is moving, you are able to track it, right? Here we are using streaming, nothing but real-time processing. We call every second will be reflected in the database. So batch processing, real-time processing. Batch processing, we use Spark. For real-time processing, we use Kafka and Apache Beam. So we have multiple options based on the client requirement. They use it. Clear? Next, SED types. So did I tell you about this Medallion architecture? No, right? Anytime I have
No,
highlighted this Medallion architecture, no, right?
no.
Okay, fine. I'll add it. Before jumping here, I'll add the Medallion architecture. Some quick recap. So we have three type of data. So based on the type of data, we choose the database. If I'm dealing with a structured, okay, I may use Redshift from AWS, Azure Synapse, GCP BigQuery. If I want to go with some third party, I have an option called Snowflake and Databricks. And then this Hive is a Hadoop, which nobody is using now. So everybody will choose Snowflake or Databricks for the storage infinity, because this guy is having storage capacity as infinity, where you will come up with the server size. Okay. Next, if I want to process unstructured data, I have an option HDFS. Okay. S3, blob storage, and cloud storage. Okay. We don't have any what we call the unstructured storage for the Snowflake. Okay, that is the reason we will depend on any of these three. Either I'll depend on AWS or Azure or GCP for processing unstructured data. Okay, it doesn't have any own infrastructure. Okay, it need to be depend on these three: S3, blob storage, or cloud storage to process the unstructured data. Okay, so this Snowflake again, it will support semi-structured data as well. I'll show you in the later classes. Done. So to process structured data, I use data warehouse. To process unstructured data, I use this data lake. Okay, we call this as a data lake, nothing but storage layer, S3 bucket. Okay, so there is a concept called data mesh. Okay, this is not that much important, but you need to understand what exactly mean by this data mesh means. So here, if it's assume you are a Google, Microsoft, or you are working for a big company, okay, all the users will not register it at one place. Okay, someone will register at Google Drive, someone will register at Gmail, someone will register at PowerPoint presentation. Some like Google has multiple applications, right? So these customer details are stored in multiple data warehouses. Whenever you are trying to call it from Gmail, they are sharing the data. This sharing of data, we call it as a data mesh. It's a centralized data management system. So where uh, I don't have any experience, but in the real time, rare and rare cases, you can see this data mesh. Okay, mostly all the companies will use this data warehouse only. Rare and rarely they use this data mesh. Okay, fine. To design this data warehouse, I have multiple proposals. Okay, what are the proposals I have? One is Inmon, Kimball, Data Vault, and Medallion. Okay, data Inmon architecture is very famous. Okay, he is the father of data warehouse. He who invented the data warehouse. Okay, in the Inmon architecture, we have three layers. One is staging, data warehouse, and then data mart. So whatever the data I extract from multiple source systems, first I will load into the staging. From there, I will process and I load it into the data warehouse. From data warehouse, whatever the business required, that I will share it into the data mart. Later, Medallion architecture came. He has renamed the staging into bronze, data warehouse into silver, data mart into the gold, and he has proposed a few theories how to process the data in these three layers. Okay. So in the bronze layer, what we do, we go with the full load, which means what I do. So first I will truncate these tables and I will load the current data. Then I will do the transformations. And here I need to use upset. It's wrong here. It's here I need to use upset. And I'll store the historical data. Whatever the business required, that data will be transformed and loaded into the gold layer. So here we are not doing any transformation. Only in the silver layer only we are doing the transformation. What are the transformations I'm doing? I'm doing data cleaning, standardization, normalization, data enrichment in the silver layer. In the gold layer, what I'm doing? Data aggregations, integrations, business logics, and rules. So if you see here, we have a concept called data modeling, where we do the data modeling in the gold layer. Okay, so we'll discuss in the next slide what is normalization, what is this, all those things we'll discuss. Okay, what is this star schema, snowflake schema, everything we'll discuss. Okay, so that's it about data warehousing, how to design the data warehouse. Okay, in the data warehouse, what we do, we create three layers: bronze, silver, and gold, and we do the transformation from one layer to another layer. Okay, any doubts? Any doubts? Any doubts? expression of concern, what this SOC is saying. So whatever the work you need to do it in that particular layer. So if you want to load the data, you need to do it in the bronze layer. Okay, if I want to load the data, I need to do it in the bronze layer. If I do the transformation, I need to do in the silver layer. If I want to create a business logics, I need to do it in the gold layer. So whatever the work we need to do, that need to be done in that particular layer. You cannot load into directly into the silver layer. You cannot create business logic in the bronze layer. So whatever the layers are there, you need to do that related things in that particular layer. Okay, so this is what actual pipeline. We have multiple source systems. By using ETL, we load it into the data warehouse. In the data warehouse, where we load it in the bronze layer. This layer is nothing but a schema. Okay, bronze schema, silver schema, gold schema. What we are doing, we are extracting and loading into the bronze schema. Okay, nothing but in the bronze schema, I have related tables in the bronze schema. First, I load it into the bronze schema. From bronze, then by using this ETL tool only, I will load it into the silver schema. Nothing but schema, this tables under this silver schema. Then whatever the data I have, business required, that I will transform and load it into this gold layer. In the gold layer, we do the data modeling. Clear? Any doubts?
Got it, sir.
Yeah. Now coming back. So while loading the data from bronze to silver, we have few techniques. Okay. If client told you to implement this SCD types, right? Okay. So what is SCD? SCD means slowly changing dimension, which means in the silver layer, in the bronze, we are truncate and load. Nothing but here there will be no data. Here we will have only business information where the complete historical data will be available in this silver layer. Okay. Now in the silver layer, we are maintaining the historical data, which means I cannot delete the data in the silver layer. Okay. Whatever the data available in the table, I cannot delete it. Why? Because in the silver layer, we are maintaining the historical records. Now, client told you to remove some data in this, assume this is a silver layer customer table. Client told you to remove some data. Okay, so or to update some values. Now, what you need to do? So, if client told you to delete something, right, you need to take the backup and store it. If client told you to do some updates in the silver layer, then we have multiple techniques. What are the techniques we have? Okay, we have total 5 SCD types. SCD means slowly changing dimension. Okay, over a period of time, client is sending in new data related to this existing data. So now what you need to do? See, client is saying, okay, these are the new customer updated details. Okay, he's sending every day. Okay, so this existing data is slowly changing over a period of time. Okay, now what is the techniques I need to use on this existing data? So that is what SCD is saying. Okay, SCD type 0 is saying, okay, if client told you this name is a type 0 SCD column, type 0 SCD column, which means, okay, in your script, you will write some script, right? For transforming data from here to here, you will write some script, right? Okay, while writing the script, do not update this name column. If client told you this type 0, which means this column will not change in a over a period of time. Even though you are getting the same details, okay, same details, okay, we will not update this script, this value, okay, over a period of time. Okay, if I'm saying this is a type 0, we cannot update or delete or do anything. Clear? Not all the columns, only the name column. Okay, what type 1 SCD is saying, just update it. No need of storing any historical data. Update the data warehouse table when dimension changes, overwriting the original data. So if you are getting the same data, if client told you this fax number this name is a type 0, fax number is a type 1. So what we'll do, we'll not do any action on the name column, but we'll update the existing record with the new value. Clear? Any doubts? See, very simple. Okay, very simple. So in the silver, I have a customer 1 Pawan, 2 Kumar, something like that. Now in the bronze data, I got this Pawan record again. Now Now, in the script, you will create a script, right? To do the transformation from here to here, you need to write some script. The script for the in the script, you may use SQL, Python, PySpark, anything. Okay, depending on the business requirement. So while writing the script, if assume this is a customer table, okay, and customer told you this name is a type 0 SCD, which means you what are the data you are getting, right? The same data. What I'll do, I'll update all the columns except name column. Okay. If client told you the phone number is a CD type 1, what we do, we will update that particular record. Whatever the data I'm getting it, right? I will update it directly. I will not store any historical data. Clear? So Pawan will not be updated, but phone number will get updated whenever the ID matches. Clear? Any doubts?
No, sir.
Let me give some example. Uh, database, e-commerce, e-commerce database అనుకుందాం. So, okay. Okay, Amazon e-commerce database. Let me create a 3 layers. Create schema, bronze. Next, create schema, gold. Create schema, silver. Okay. Create a table. So let me create this. I'll clone this table into this e-commerce Amazon. Okay. Create table. LD means loading table. LD products. This. Okay. Next. Let me create DWH. Okay. So here I'll add 2 extra columns. Start date, comma, end date, where product ID equal to 1. So here, if you see here, select star from this. Okay. So I have a data warehouse table with product ID 1. It has 2 columns, start date and end date. Okay. Done. So I have a table called LD products. Nothing but okay. Let me drop this drop table. LD product. Create table bronze. This is in bronze level table. So table in bronze table, bronze layer, and now one table in DWH product. Okay. Now what I want to do, I need to update. I want to insert the data from LD product to DWH product. Okay. In both the tables, I have a common record, right? Let me put bronze dot. This is silver table. So I want to load data from bronze to silver. Okay. In the bronze table and the silver table, I have one common record. Getting it right? Okay. So this ID one already exists in the DWH product. Now, if client told you this product name is SCD type 0, which means you will not insert any record, will not update this product name or product ID. Okay. If client told this price and this vendor stock are type 1 SCD, which means we will update the data, we will not store any historical records. Getting it right? Getting it right? Now let me write update. So we have a concept called merge. Let me do one thing. Okay. So for return, okay, if you see here, so what I'm doing, I'm merging the data with the DWH, okay, using using LD underscore products. Okay. No, not batch 48. We need to use this thing. Okay. Using this branch. Okay. Now what I'm doing, when ID matches, then what I'm doing, I'm updating the all the records except product name. I'm not updating the product name because this product name is type 0 SCD. Okay. When it comes to price category or type 1 SCD, which means I can update it. Getting it right? So if I execute this query, product ID and laptop are the type 0 columns, which means I'm not updating this value. What I'm updating? I'm updating the category and price with a new value. Clear? Any doubts? Team, clear. This merge is a DML command. As
Yes.
of now, we have discussed insert, update, delete, and you need to add now merge command. What merge will do? Whenever the condition is matches between both the tables, it will update the data. When condition not matches, it will insert the data. Simple. Clear. When matched,
Yeah.
then update. When not matched, then insert. Done. Let me execute this query. Product ID only. So I think we have written product ID wrong. So this is the product ID. Let me execute one more time. Product name. So now if you see here in the DWH product, let me call this DWH product. So you can see this laptop has updated. You can see here current timestamp. Okay, sorry. Yeah, this laptop value has updated. Remaining all the values are inserted. Clear? But here product ID and product name are SCD type 0. That means this value is not updated. When it comes to category and price are type 1 SCD, which means I have updated the record. So this is type 0, this is SCD type 1. So in the type 0, we will not update the existing values. That values are completely static, which means the value cannot be updated. When it comes to type 1, we will update the value. We will not store any history. When it comes to type 2 SCD, this is very important. Here, what I'm doing, here I have a two columns, start date and end date. Okay. If I'm getting the same record existing in the table, then what I'll do, I will not delete the current record. What I'm doing, I'm updating this end date. Then what I'm doing, whatever the new record coming into the table, right, that I'm inserting here. Clear? Any doubts? Okay. So in the SCD type 2, what I'm doing, I will not delete the historical record. I will maintain the complete history. Okay. Let me go with the example. So let me delete from this table. Okay. Where product ID not equal to 1, which means all the records will be deleted except that product ID 1. Okay. Now let me go with the silver table. Select star from bronze. This. Okay. Let me update the ID 1. Update this table. Okay. Set price equal to 100. Okay. Where product ID equal to 1. Now assume today I got this product price as 1200. Okay. Now this price column is a SCD type 2, which means you need to maintain the complete history. You need to maintain the complete history. Okay. So what we do, we'll not touch the existing record. In the existing record, we are updating the end date. Then what I'm doing, I'm inserting the new record. That is what I'm doing. So let me write the query for the same. Okay, what I'm doing, first I'll updating the end date. Update, or I can use merge also. I'll go with the merge command. All on coronation. Okay. What I'm doing, okay. So if I want to implement SCD type 2, what I'm doing, if the ID matches, I'm updating the end date and I'm inserting all the records. Now, if I execute this query, now you see in this table, in the silver table, what I'm doing. Okay, you see here, this laptop, okay, it has a price 150 rupees from 38, assume it's 2025. From 2025 to 2026, the price is 150. Okay, from 2026, the price is became 1200. The price became 1200. It is not properly updated here, but so I have updated I forgot to execute this command. That is the problem. I forgot to execute this command. Okay, what I'll do the truncate. Again, I'll load it. Truncate this thing. Done. Let me execute this command again. Now order by product ID SNE. Okay. Oh, got it. Let me truncate. Where product ID equal to 1. That means at one record. Okay, I have inserted this one record, which means the product ID 1 already exists in the table. Now let me execute this std type 2. Okay, now you see here, if you see here, so in the silver table, the product ID 1 already exists from where? From 2025 to 26. Now, but I have updated this as a 1200, right? Shit. Okay, you got it right. Or what exactly I'm doing. Okay, so here I have mentioned the table name wrong. It should be bronze and it should be, sorry, it should be e-commerce Amazon. It should be silver, this bronze layer. Okay, so here what I'm doing, okay, there is an existing record laptop and I'm trying to insert the same record as it client told this table is SCD type 2. Okay, these columns are SCD type 2. You maintain the historical records. That is the reason you will add two columns, start date and end date. Okay, whenever you are trying to insert the same data, you will update the existing record null date. Okay, and the new record null date should be null. By storing data like this, you can easily understand, okay, this product price is 150 from this date to this date, 1200 from this date to this date. Clear? Any doubts?
No, sir.
Okay, we'll end up class up to here. Tomorrow we'll discuss 3 and 4. Okay, see this SCD type to nothing but, okay, this SCD type to nothing but, see, whenever we are storing the data in the silver layer, right? So we need to maintain the historical records. In the silver layer, we need to maintain the historical records. To maintain the histories, we have few theories. One is type 0, which means that column we will not update it. While writing the script in SQL or Python or PySpark, you will not update this column. If it is a type 1, we will not maintain any history. We will update the record. In the type 2 SCD, what we do, we maintain the history. How we can maintain the history? So we have it two columns, start date and date, end date. Okay, whenever the record is inserting, the end date will be null. Okay, if you are getting the same record in the over a period of time, okay, what we'll do, we'll update this end date and we'll insert the new record in the next row with a
So
null value.
will the client tell us to use SCD type 1 or type 2?
Yes, client will tell you. So what you need to use a type 1, type 2, and type 3. Okay, so in the documentation, you will get a SCD implement type to SCD on this table related to this column. So that you will create you will insert you will write the script for inserting the data like this. Clear? Any doubts?
Okay.
Yeah, tomorrow we'll connect to discuss the remaining. Last time I'll show you. Let me truncate this. Let me insert one record where product ID equal to 1. Okay, let me change this to bronze. Okay, now let me execute this query. Okay, we already have this 1200. Okay, in the bronze table, the product new record over a period of time, I got this new record as 1200. Let me let me execute implement this SCD type 2. Does not exist or not authorized. Now you see here. Okay, assume in a table this record is there. Okay, product ID already exists. Okay, if I and here the price is SCD type 1. Okay, so you see here. Okay, so this 150 rupees is from 2025 to 26. What are the new record inserted? It is 2026. If the end date is null, which means this is the active price in the e-commerce application. Clear? Any doubts?
No doubts.
Clear? Yeah, thanks all. We'll connect tomorrow. Not tomorrow, on Monday.